Our chair for session 5 is Henrik Friis. Henrik is a medical doctor. He's a former lecturer of epidemiology and now professor of international nutrition and health at the University of Copenhagen. Over the last 30 years, Henrik has conducted health research with colleagues in many African countries on various topics, most notably on the interactions between nutrition and infectious diseases such as HIV, tuberculosis and parasitic infections. Over the last 5 years, Henrik has focused on the prevention and treatment of acute malnutrition. He's also a keen bird watcher and bird photographer, and he has been known to become a little bit distracted when he's at African meetings, when the action outside the room proves to be more luring than what's happening inside. So we are now safe because there are no windows in this room, Henrik. Over to you.
Thanks a lot. I noticed that about the windows, so I'll remain focused. Thanks a lot, and welcome to this session 5 on impact assessment in MAM, focusing on methodological challenges. Rapporteurs are Kay Dewey, University of California, Davis, the USA, and Kim Fleischer Michelsen, University of Copenhagen, Denmark. In fact, most of what I wanted to say to justify this symposium has already been said repeatedly during the previous days. And that basically is that there's a strong need for evidence, a strong evidence base for interventions to prevent and treat MAM before they are taken to scale. At the first day, Aileen Kennedy said that evidence is important, advocacy is key. I fully agree on that, but want to add that evidence is also key to advocacy. If we really want policymakers and decision makers to do more to fight MAM, then we also need to provide the evidence. And if we don't, then we can't blame them that they want to put their money into other sectors where there's better evidence and where they may feel more likely to get something for their money. Yesterday, Patrick Webb, based on his review on the evidence from systematic reviews and meta-analysis, emphasized that although a lot is known, the evidence is grossly inadequate. I fully agree on that. Rebecca Grace then emphasized that there's a need for not only randomized trials, but a whole range of study designs, and because we also need to address programmatic issues and evaluate programs and so on. I may be one of the randomistas Rebecca referred to, but I actually agree, and in most studies there's a need not just for different designs, but also for both quantitative and qualitative approaches. In this session 5, we will first have 2 presentations and then a question and answer session before the lunch break. And then after the lunch break, we'll have 3 presentations, all from people who have done big trials under different conditions, and we'll discuss not only the results, but certainly also, first and foremost, the methodological challenges of getting the good methods into the field. I'm going on to talk about study design issues in trials among children with MAM. But just a few thoughts before I zoom in on study design. First, it's quite clear that we have obviously a major problem defining what we are talking about. For SAM, because we are using very crude measures of growth to define acute malnutrition. For SAM, different children are identified using one or the other of the indicators. For MAM, it may even be worse, and the definition of MAM is still under debate, I understand. Second, as you can see to the left here, whatever indicator we are looking at, it's fluctuating over time due to season, due to infectious diseases, due to conflicts and natural disasters and so on. So we have a couple of problems. One is that acute malnutrition is not well defined. Another one is that nutritional recovery is not really biologically meaningful, because due to these fluctuations, the impact of nutritional programs seem to be or the rate of nutritional recovery seems to be somewhere between 25 and 95%. Jonathan has already argued that body composition is a key outcome. Obviously, in SAM research, as you can see down here, survival is a key outcome and should be in most studies. For MAM research, body composition could really be a key mediator of the effects. It could explain some of the short-term effects on child development and physical activity, as well as immunity and infectious diseases. And these short-term outcomes could again mediate some of the long-term outcomes, such as educational achievement, working capacity, but also risk of chronic diseases and infections. All these outcomes are obviously also of relevance for survivors of SAM. Now I'll first talk a little bit about the ethical and scientific issues we have to deal with when deciding on which study design we're going to use. After that, I'll talk about the different design options and some, especially on about the randomized controlled trials, but also some of the special sub-designs. And then eventually I will give a few examples. As for the ethical concerns, it mainly relates to the choice of intervention and control group. Even if we are doing or want to do a study in a setting where there's no recommendation, as researchers, when we go in and take responsibility of participants, we have to ensure that what we are giving is not putting the participants at risk. There has to be what is called equipoise, that is, there has to be uncertainty as to whether the intervention or the control intervention is better than the other. We also have to make sure that the methods of examination that we are going to apply are not potentially harmful or unnecessarily burdensome for the infant, for the child. Examinations which can be justified on a clinical indication are not necessarily relevant or cannot necessarily be justified in a research setting. On the other hand, I think it's also very important to be clear that suboptimal research methods are also an ethical issue, an issue of research ethics. Because if we want people to be included in our studies, we need to make sure that the results from the study will make sense. So we cannot apply suboptimal methods. Another issue I think is important to mention is that lack of research is definitely also an ethical issue. Researchers are not to blame, but usually they will be happy to undertake those studies. When talking about the scientific issues, it's really the usual suspects, that is, confounding and biases, which may give us spurious results. Fortunately, we have some tools to apply. We can use randomization to deal with confounding. We can actually considerably reduce, if not even eliminate, confounding, depending on the numbers of participants. As for biases, we can try to use blinding to reduce the risk of information biases, and we can use allocation concealment, and we can also maximize adherence and follow-up to deal with selection biases. And of course, as mentioned by Patrick Webb the other day, that also requires that the analysis is appropriate, that we are using intention to treat analysis, and that the reporting is also up to standard. Generalizability of data from nutrition trials are really difficult, and I think much more so than for when studying the effect of drugs. And why is that? Well, that's partly because the background status and the background dietary intake is usually unknown and very, very difficult to assess in a given setting. Also because nutritional deficiencies are widespread, and not only that, also because they often coexist. multiple deficiencies coexist and they interact at the same time. And finally, because high infectious disease burden may actually affect metabolism of nutrients. So I think we have to accept that the effect of the same intervention is actually likely to differ between individuals and between different populations. So we should be prepared that data will be inconsistent. I would like to take you through this conceptual framework, which was actually developed to assist interpretation of nutrition trials. What you see on the x-axis is before and after situations, which could correspond to the placebo group and then the intervention group. On the left axis, the y-axis, what you have is the effect or the risk of an adverse outcome we are interested in. And then the different boxes here you see say something about the nutritional status of a specific nutrient. So the white boxes reflect a low nutritional status, severe deficiency of a specific nutrient. The gray boxes, mild or moderate deficiency. The dark gray boxes, normal status, and then the black box, an overload of a nutrient. And then, of course, the difference between before and after reflect whether the risk is going up or down. First, if we have a situation where we do a trial and there doesn't seem to be any effect on the outcome, then there could actually be several different interpretations of that. In scenario A, you have a situation where there was a deficiency to begin with, and the intervention actually enabled us to normalize nutritional status. So here we may be able to say that this nutrient apparently did not have any relationship with the outcome of interest. In scenario B, you have another situation where there is a deficiency, but then the intervention was not really able to replete the study population. So we can't really say if it works or if the nutrient has an effect on the outcome. And then finally, in C, you have a situation where the status, the intake or status of the nutrient was already adequate. So the intervention did not have any effect. So only in scenario A do we have a situation where you can really say something about the nutrient in relation to the outcome. Then in figure 2 here, we have a situation where A, B, and C, where the nutritional status was normalized in all situations. But then if it was in scenario A, then we see a big effect because the population was really deficient. We see a smaller effect when given to a population with only a moderate deficiency, and we see no effect if the status was already adequate. And then down here, it's similar, except that in this situation, when giving a nutrient to a population that was already having an adequate status, then there's actually a harmful effect. And for example, this here could be applied to the data from the PEMBA trial, which I'm sure most of you will know of, the study at Zanzibar, where an iron intervention seemed to be harmful and the study had to be stopped. And then a subgroup analysis showed that, yes, it was harmful, but only when given to children that already had adequate iron stores, whereas it seemed to be beneficial for those who didn't. And then you can have a situation where the same intervention that successfully repletes individuals actually have other beneficial or no effect or even a harmful effect. There are also examples of this here. One example could be the vitamin A data some years back when more or less the same vitamin A intervention was proven to actually increase mother-to-child transmission of HIV in Tanzania, whereas there was no effect, neither beneficial or harmful, in similar studies in Malawi and South Africa. And if this is not already too complicated, we also have to think about the possibility that the same nutritional intervention may actually have harmful effects on some outcomes and beneficial on others. So, of course, there are situations where we are not able to do a randomized controlled trial. We'll have to rely on non-controlled or intervention studies or non-randomized studies. And that might be the best we can do, but it doesn't change the fact that such studies, by definition, are biased and confounded. So the question is if they are really worth doing, or even put it the other way around, the question is if we could, by discussing it at an earlier stage, if we could in fact have probably randomized such a study. So in the following I'll go through some of the different study designs. In the normal randomized controlled trial, we usually want to test the effect of an experimental intervention, a new one, to a control intervention. And the best one from a scientific point of view would obviously be to have an unsupplemented intervention group, just as you do in a drug trial. That's much more difficult when we're talking about undernutrition. The problem is often that an intervention has already become a standard of care without any evidence. That gives us a couple of problems. First, it will be very difficult to go back after this has become standard of care to actually test it against an unsupplemented intervention group. That was actually what was possible in the PEMBA trial. But usually it will be very difficult to persuade ethical committees to do that. Second, if we want to test a new intervention against the existing standard of care, then the problem is that since we don't know the effect of the standard of care, then it will be very difficult to interpret the data. And you could actually imagine a situation where the apparently beneficial effect of an experimental intervention simply reflects the fact that the standard of care was harmful. Again, there are examples of this. Another problem is that there's an infinite number of potential diets to test in a given trial, because we can have different combinations of the different nutrients, different doses of nutrients, forms, quality, different processing methods, and so on. But usually, since trials are hugely expensive to conduct, we can only choose one or a few at least. And finally, we have this problem that it may be very difficult to have individual allocation. But what I've just mentioned here is something that we can try to deal with using the appropriate design. One of those I'm going to mention is the step wedge design, where actually you ensure that everybody are getting the intervention. It's just that they will be randomized to the timing. So there will be a randomized sequential rollout of the intervention. It's not used a lot, but it could be used more often, especially if you already have an intervention that has been decided to be rolled out. Then as you do so, you can actually assess its effect. So there has to be a prior belief that the intervention is better than the control. And there has to be a situation where it's not possible to give it to everybody at the same time. So under these conditions, there shouldn't be any ethical issues related to the randomization. The disadvantage is that it's more difficult to prevent information bias because it's difficult to blind. It is also more difficult to the randomization will be less efficient because the number of units are usually lower. Very often it's done, but then for some reasons it's not randomized, which is unfortunately. This is the design or the structure of such a study, where, as you can see, everybody at one point are getting the intervention. It's just the timing that is different and randomized. Actually, it has been conducted in the field of MAM, and some of the people participating in this meeting are actually behind this study, like Mike Mannery and André Briand. You're not supposed to read the text here. Then we have the cluster randomized trial, where you randomize not individuals but groups of individuals, clusters. The advantage is that it's logistically much easier to do, and there's a lower risk of spillover from one group to another, or contamination of the control group, as you could call it. The disadvantage, again, is that there's confounding is more an issue because you need a big number of clusters to effectively control confounding. Because the sample size in such a study is actually not the number of people, but the number of clusters included. because the individuals in each cluster are not independent. They tend to be more similar than people between clusters. So you need to have a larger number of individuals participating. Then we have the factorial trial design, where you want to test 2 or more interventions at the same time. And the advantage here is that it's possible to test for interactions between different interventions. And since interactions are very often taking place between nutrients, then this is a very useful design in nutritional studies. What I mean by interaction is that the effect of one of the factors you want to test depends on the presence or absence of the other factors. If there are no such interactions, then you actually have massive power, because then you can look at each of the interventions consecutively with full statistical power. The disadvantage here is that you may need a larger sample size, because it could be that there are some interactions, and the analysis plan is also more complicated. On this slide I show the design. You see you have 2 interventions, A and B, and both of them are controlled. So you have 4 different combinations of those 2 interventions. And again, if there's no interaction, that means that the effect of the difference between A, B, and B here, which is the effect of A, if that is different from over here, where there's no B intervention, then you have an interaction. But if not, then you are actually able to compare all those in the A, the marginal numbers here, with non-A. So you have the full statistical power of the study. And then after that, you can look at the effect of B. Then if there is an interaction, then you will need to do some comparison between the cells. But then, on the other hand, you have got some very useful information. Now, I'll use the last rest of my time to give a few examples from 2 of the studies that we have been doing or are doing. One is the TreatFOOD trial. It's based on a collaboration between University of Copenhagen and MSF, Doctors Without Borders in Denmark, because we thought that a combination of an NGO wanting to do as much as possible in emergency settings, and then a university where we want to do our research, that combination could be useful, because the compromise would be that we would be forced, as researchers, we would be forced to answer the right questions. In addition to those 2 partners, we also have a lot of other people involved from the World Food Programme, WHO, MSF, Epicenter has been very much involved, and other researchers. The trial is implemented with the NGO Alima in northern Burkina Faso, in Yako, as indicated here. And it started September 2013, and we will hope to have a report in July 2015. The main aim was to really to develop and test the effect of new foods. And the question that we wanted to answer was based on the fact that we thought that not only quality was important of the food products, but also the cost of it. Because if we increase the cost, then there are less children that can actually be helped. So the starting point was CSP products and LNS products, and we wanted to see if we could try to improve the quality of CSP without increasing the cost very much, at least. And also if we could make LNS products, as they are prepared for STEM children, make that cheaper without losing its effect in MAM children. One of the big issues here was, again, the control group. At an early point in the discussions, when we thought it was going to be implemented in another country, a lot of the partners in the consortium actually felt that it would be easier to justify ethically to have an unsupplemented research control group than to have a CSP plus. Then eventually the study had to be moved to Burkina Faso, which we are now happy about, but in Burkina Faso CSP was the standard of care, so that then became the control group. This is the design. It's a bit unconventional. It's a 2x2x3 factorial design, because we really felt that, although complicated, this is what we need to provide the answers to the right questions. So we randomize 1,600 individuals, children with MAM, between 6 months and 24 months, to different products. The 3 factors are the matrix of the supplement either CSB or LNS, then the soy quality, which is either dehulled or isolate, and then 3 different levels of milk. Had we done this study on our own, we would probably have used the normal approach and trying to have a big contrast in the exposure, maybe comparing A versus L, and then have a maximum sample size and power. But what we did here, having all those 12 groups, actually allows us, after testing for interactions between the interventions, if there are none, then we can actually say, irrespective of the matrix, irrespective of the soy quality, then what will the effect relative to the cost be of adding 8% of milk to this product? So we will in that case be able to look at the effect of the individual factors. And some of the products here actually are very similar to existing products, so we get some information about where we are relative to known products, as you can see here. A and B are very similar to the CSB Plus and CSB Plus Plus, and H and L corresponds also to some existing products. In addition to the design, we also wanted to have very good outcomes and to take really the best outcomes into this very difficult working environment. As primary outcome, we have lean mass increment to 3 months of supplementation. The duration of supplementation was 3 months, and then we followed up the children for another 3 months. So that's our primary outcome. And then in addition, we have anthropometry, and we also have thymus size assessed using sonography. And as among the anthropometrical measures, we also use knee heel length, or we measure knee heel length. Then we look at morbidity, physical activity measured by accelerometers, child development, and then a range of laboratory measures, including essential fatty acids and iron status markers. And then we look at acceptability and adherence to the products. Let me just show you here. To the right, what you see is to get all these individuals through the different measurements. There's a lot of logistical challenges, and on the photo you see one of the tents, and we have 5 different sites where this is taking place. Just to show you how knee heel length is measured by a anemometer, which Kim Fleischer-Michelsen has developed. It gives very precise and accurate measures of linear growth. This is the TreatFOOD website, and you can read more about it. And here we actually submitted our protocol for review by the Lancet. That's a service they have, and if accepted, which it was, then the summary is published on their website, and they will promise to review the paper. And this was, I think, much to our surprise, because the design, at least, was very unconventional, but they actually was quite happy about it and had some constructive comments to the plan of analysis, which we have taken into consideration. The last few minutes I'll talk about another trial, which is actually slightly different, because this is a trial, a nutrition intervention trial among adult patients with HIV conducted in Jimma, Ethiopia. But I think there's a few things that are relevant for this discussion. As you can see here, we actually have a delayed intervention. We randomized people with a BMI between 16 and 17 were randomized to 2 different LNS products with whey or soy protein. And I'm not going to talk more about the differences really, but so those that are undernourished with a very low BMI are randomized to an early intervention, but with one of those 2 supplements. And then for the subsequent 3 months, they are not supplemented. For those with a higher BMI, above 17, we randomized either to LNS with whey or with soy, or to a delayed intervention. And the justification for this was really that many HIV patients and other people with infectious diseases have anorexia, and the anorexia may actually be beneficial. It may be a sign that maybe the intake of food should not be exaggerated at an early stage. So we thought that giving the same supplement for 3 months but delayed might actually lead to a better effect in terms of lean mass and functional outcomes. At the same time, of course, it gave us an opportunity to have an unsupplemented control group, which is really essential. Actually, there's a Cochrane review on nutritional supplementation, but the problem is that one of the requirements is that they only include studies with an unsupplemented research control group, and the fact is then that it's only a few studies from the US that will actually qualify to be included. So again, there has to be equipoise. We have to argue why there are reasons to believe that it would be beneficial to give it later. And in this population, mortality was not an issue. Mortality was very low in contrast to other settings. But I would actually say that you could probably also argue for delayed intervention even in settings where there's a high mortality. You may have heard that there has been some concern that the very high mortality in some settings is actually due to a refeeding syndrome. That there's an ART related hypophosphatemia. Let me just show you a few of the results. To the left, what you see is the increase in weight. In those with the dark solid line here are those who have been supplemented for the first 3 months compared to the unsupplemented here. So the effect is quite considerable. They have almost a 3 times or more than a 3 times increase in weight. What is interesting is that when we stopped supplementation and followed these individuals up to 6 months, then they actually lost weight. And if we didn't have body composition data, we might have concluded that, well, we should probably continue giving the supplement, not just for 3 months, but maybe 6 months, maybe 9 months. But if you look at the body composition data, what you can see is that the weight decline was only due to loss of fat mass, and at the same time, accumulation of lean mass actually continues. We also looked at the effect of the intervention stratified by clearance of virus. It's a bit complicated, but after 3 months, some of the individuals had cleared their virus, others hadn't yet. And what we found was that those who had cleared the virus after 3 months only accumulated lean mass, whereas the others only accumulated fat mass. That effect was really huge, and that's something that we're going to follow up on. So the 3 points I want to emphasize based on the TreatFOOD study here is that body composition is really essential to make sense out of the data. Also that a delay to supplementation may be beneficial. And the third thing is that inflammation may be a crucial factor that could also be relevant to consider in studies on MAM. So in conclusion, there's definitely a need for cost-effective intervention, and there's a need for very good data before interventions are scaled up. And we need randomized trials, but there could be some special designs that could be applied. The choice of control group really poses some both scientific and ethical concerns which we need to address. And the question I want to end with is if we should consider or under what conditions we think we can justify unsupplemented control groups. Maybe we can talk about that during the discussion. Thanks a lot.
Okay, given that Henrik is 50% of the presentation so far, I'll handle the questions so that he can think about the answers he's going to need to give. So we've got about 25 minutes. A question from over here, down here, and Dr. Tarmond, and then I'll come to this side.
Thank you very much. My question is for Dr. Fries about the designs for evaluation. If you did a wordle of the discussions we've had over the last day and a half, I think context would come out as a very important one. And we can keep doing randomized controlled trials and find heterogeneous results without being able to explain what's going on. So I would strongly advocate to to any design, any evaluation we do, a strong process evaluation component where we take an in-depth, more qualitative look at the impact pathways to document whether the program was delivered, whether people showed up, how utilization was, what barriers to utilization might be. And then related to your conclusions, you say we need cost-effective interventions. The only way to know if things are cost-effective is to also do solid cost studies related to those. So we need to document the impact with the strongest possible design, but we also need to open the black box of the impact pathways and document what all these things cost to move forward in this field, I believe. Thank you.
Bridget?
Yeah, thanks both. Very interesting, and I've certainly learnt quite a lot. Actually, my question is very similar to Jeff's, and it was about generalisability. And I'm just wondering if, if the panel could recommend how we could try to optimise our study designs to ensure greater generalisability statements in operational settings, especially when faced with such contextual differences that not only occur between countries, but also within the same settings.
Thank you very much. Both the presentations are really fascinating. My question is to Dr. Fries. We are, battling with ethical issues and also the need for a real counterfactual so that we can have the real evidence. And I think the step-wedge design serves both the purpose. But as you rightly mentioned, that the absence of, randomization. So the question that I have is, how much does that weaken the strength of this very useful design, the absence of randomization?
As for the first question about process evaluation and the need for other studies, I fully agree. And you could also add a lot of other qualitative studies, which we are usually also doing in relation to these studies. And it also goes for cost-effectiveness studies. I really fully agree on that. Then there was a question about generalizability. And my point was that, well, it is more difficult to generalize, and we should expect heterogeneity. But one of the ways forward would be if we could have a much better characterization of the different study populations, contextual information, as you mentioned, but also in terms of nutritional status. And the problem we are having here is, of course, that the methods we have to characterize, especially micronutrient status, in the populations where infections are widespread, are really difficult. So there's a need to develop those methods, and I think it is possible somehow to try to adjust for the impact on inflammation. So technical issues is one thing. Another thing is the cost, because the trials are usually very expensive and underfunded to begin with, and we usually want to do a whole lot of things which we can't afford. So more funding, but also cheaper methods would be probably be a way forward. And then it would be nice to, if when conducting a bit study, if we could be conducted in parallel in different countries, which is sometimes done, but with limited funding, of course, that's not necessarily easy. As for the step-wedge design, I think I actually said that it can be randomized and it should be randomized, but in a recent review of step-wedge design studies, the authors conclude that for some reason the step-wedge design is used for implementation because they are not able to implement all places in once, and they had the possibility of randomizing, but often it's not done. So it should be done, and if there's enough of units, then that should take care of potential confounding at the same time.
Maybe just to make maybe just to make a comment on heterogeneity. I think as long as we keep looking at MUAC, weight for length Z-score, which we treat as the same in all populations, we'll never see any variability underneath. I think because I've spent many years working on body composition, I expect variability. When you're looking at adult populations around the world, their physique and their adiposity, their fat distribution, all vary tremendously, as does body size. Obviously you get to being an adult by growing as a child, so we should expect patterns of growth in early life to vary as well. Now we have the WHO growth charts which show that populations from very high quality conditions grow relatively similarly. But when we're working with populations from more heterogeneous conditions, we know that they grow into adults who have variability in their body size. So I think if we switch from using anthropometry to focusing on body composition, we'll see a lot of variability that we're missing now, and I'm sure we'll learn a huge amount from that about what matters in a given population for mortality risk, for other aspects of healthy development. But we won't see that until we bring the techniques and start looking.
Okay, I'm going to move to the side of the room. Emon, the gentleman there, and the lady there.
Emon, Mahidol University, Thailand. My question is to Dr. Wells, and interesting presentation. Does it matter where the body fat is? The adiposity and the dilemma of the Indian babies that we have heard for years, central adiposity, during growth, does it, in your study of the parents, where one European parents and those, is it different where the body fat is being distributed? And do you think that several of the studies that come out as fetal adiposity during pregnancy is something to be noticed and observed for certain risks of obesity and non-communicable disease in later life?
I certainly do think fat
Thank you, the presenters, for a nice presentation. My name is Andres Munyeki from Northwest University, South Africa. The presentation by Jonathan Wells on body composition, by saying that there is a need for references for various people, I concur with him, because there is a publication by Cole, 2007, wherein there is a classification of thinness of the children, especially from the low socioeconomic status, wherein the thinness is also been classified to the extreme of 3 categories, 1, 2, 3. So I want him to comment on this issue based on all this reference that we have, because when you look at South Africa, based on the different ethnic groups, and the fact that when you look further, that the South African women, they are pear-shaped. They are not, even it starts when you are young. The child, when he's young, also will still experience that. And when you look at this, the SEMA and the MAM, and also standing is an issue. I want you to at least try to comment on the reference, how we can come up with a reference that are specific for a particular population, even though we know that MAM and SAM is available in different areas.
I'm Charlotte Wright from Glasgow. My main sort of comment question for Jonathan is, he briefly mentioned skin folds. I mean, for most people with limited funding and the practicalities of running trials, skin folds are a very low-cost option compared to stable isotopes. And I can commend, we've used them in very young infants very successfully. The WHO standards, give you something to compare them to in preschool children. And really, we found them to be very indicative and informative in looking at nutrition risk. And secondly, a comment. Archie Cochrane is spinning in his grave to suggest that it's unethical to have untreated control groups. While there's still equipoise about whether a treatment works, we should have untreated control groups. It may be very difficult to persuade people, but it isn't unethical.
Okay, my question is to Jonathan. For information, you know that we are processing with WHO, developing standards of children up to 2 years of age, and this is in different settings. So my question to you is this inconsistency between body composition across population, is it really due to the population phenotype or genotype, or is it due to technical or the methodological aspect?
Okay. The answer about fat distribution, yes, it really does matter, but maybe not in an equal way across all populations. Oh, sorry. Is this on? No? Okay. Speaking the wrong way. I think fat distribution does matter, but maybe not exactly in a homogeneous way across all populations. In general, we know that central adiposity is more harmful than peripheral adiposity, but we need to understand that that may be because the central fat is bad or because the peripheral fat is good. We need more research efforts to understand both depots of fat and what they do and what the consequences are when treatment or illness starts to affect fat distribution. In terms of the question about South Africa, I think what you were asking is how can you develop reference data if you have high levels of malnutrition in the data? I think the answer is that we can make a difference between a gold standard and reference data. A gold standard is in some sense what we think everyone could aspire to if they had the optimal conditions for many generations. A reference is simply what you are seeing in a population, and you'll always be able to say that some people are doing better on that reference rather than others. And I think you would probably address that question if you went and collected the reference data, and then you could use various approaches to analyze it. In terms of skin folds, I completely agree. Skin folds are fantastic. In my experience, researchers are far more scared of skin folds than young children. People don't want to apply them, but we've never had any problem collecting data in large data sets from younger age groups. What you can say about skin folds is that you're not getting the whole body fat, you're getting the subcutaneous fat, and therefore you may not be getting a picture of some aspects of adiposity that are important. And you're not getting any information about lean mass whatsoever. In terms of other differences between populations emerging because of methodology or because of biology, I think there's a wealth of evidence now that biology is the dominant factor, and we know that because we've measured body composition across ethnic groups with all sorts of different techniques, and we consistently get the same messages. Ethnic groups really do differ in a number of different parameters of body composition. But because this is a relatively new research issue, we don't have that much information about what's causing these differences. Are they genetic? Are they epigenetic? Do they emerge in the life course? And so on. And again, that's going to be a very rich area to explore, because I think if we can address differences in body composition, we may have a better idea of another issue that's emerged at this meeting. When is treatment actually useful and important? Are you treating the right children? Are you treating the children who are genuinely undernourished now? Or are you pushing treatment at a problem that actually manifested in a previous generation, in which case is using treatment now unrealistic? These are all questions we don't know the answer to, but I think body composition will help obtain those answers.
Yeah, just a comment actually to Jonathan. You mentioned that fat is really important in itself, and that it may have some beneficial effects on the immune system, and it's much more than just an energy store, and I fully agree on that, although it's not really my field. But I just want to underscore that, of course, if the diet is inadequate and if there's a lack of some of the growth nutrients, then it means that energy will be deposited as fat at the expense of lean mass, and the same growth nutrients are usually also important for the immune system. So that in that situation, fat will be associated with impaired immunity.
I mean, one set of analyses that we've done recently is we've gathered all the skin fold data that we could find around the world, and we analysed what they were associated with. The triceps skin fold was associated with mean annual temperature in a population. As the environment got colder, populations showed higher levels of triceps, although the association wasn't extremely strong. When we looked at pathogens, and for temperature there was not really a detectable association for the subscapular skin fold. But when we looked at pathogens, we saw the opposite. As you had more pathogens in the environment, you saw no association with the triceps skin fold, but you saw a lower subscapular skin fold. So the suggestion is that if you're in a rich pathogen environment, you're not able to deposit fat in your central adipose tissue, presumably because that tissue is doing something about your immune function. So we're already getting messages about some of the functions of fat and the fat distribution, but that was very much a first look, and we need a lot more information about these kinds of things.
Let me just add, I didn't do that during my presentation, that in the art food study, the HIV study I referred to before, where we saw this continued accumulation of lean mass even after stopping the intervention, there was actually a beneficial effect on the immune functions as well. So we strongly believe that there's a link between that the lean mass is either accompanying or mediating the effect on immune functions.
Wonderful. I'm just going to take those two questions on the right-hand side, gentleman in the middle, and Dr. Tulukta and B.
Okay. Muhammad Ali again from Sudan. I admired both presentations actually, and they're excellent to me. One question about your experience. Have you done anything related to specific micronutrient? For example, we are doing something in Darfur, and we are finding a lot of toxicity levels. And unfortunately, the iodized salt is distributed by the different organizations, and you tend to find a lot of very high levels of urinary iodine in the samples. Have you done anything on a micronutrient, specific micronutrient, where we could extrapolate on, or where could be useful for us?
Yes, I just wanted to ask Professor Fries about the use of local foods in your trial, whether you considered having them as one arm or it was not an option, and what are the difficulties of doing these trials using local foods rather than commercially produced foods?
Thanks. I just wanted to make a comment about the discussion of cluster randomized as opposed to randomized trials. I guess I have two points that I think it's important to keep in mind. One is that the validity of a study is based on things besides that, and when you don't cluster randomize, you have, as you mentioned, you can have a real risk of contamination. So there are certainly many situations in which you can't possibly randomize by individual because it's just not feasible to do that. But the other point, I think, and of course you want as many clusters as you can to maximize variability, but I think it's a little misleading to assume that all of the households served by a particular clinic, for example, are as similar as all of the cells in a rat's liver. That is to say, you're going to get some variability. And so I just think I think when you're looking at the cluster randomized versus individual randomized, you have to keep those constraints in mind.
Okay, given that was a comment, I'm going to take somebody who's going to burst earlier in the pink shirt over there.
I don't know whether I'm really at risk of bursting. I know I'm getting fatter. I didn't know that was quite such a serious issue. I just want, I don't know that it's a question, but it's to either speaker. In talking about fat and fat partitioning, one of the more important things that Pon showed us in relationship to immune function is that the fatty acid composition in and around immune competent organs is of a very different profile to the fatty acid composition in other sites. And so that when you're moving from a structural statement about body composition to a functional statement about immune competence or whatever, that has to be taken into account. And I just wonder whether in any of your studies you have looked to see the relationship between the fatty acid profile of what you're giving and the fatty acid profile or partitioning of fatty acids in different sites in relationship to the considerations you raised.
Let me start. There was a question about micronutrients, and certainly we've been doing studies on micronutrients, but there are many more people here with more expertise on that. And as for iodine, there are also expertise in the panel here. So I'm not able to answer that question. As for local foods, we fully agree that that could be a way forward, that there can be local solutions, and we'll hear more about that in the presentation by Victor Vino today. So that definitely should also be a way forward, but there's also a need for products that can be scaled up and distributed all over the world where there's a need. So I think it's not either or, it's actually, there's a need for both. And about cluster randomized trials, I haven't done one myself, but there are different approaches, and one is to, of course, that for each cluster you get a mean value or proportion, and then you work with that, so you can actually do a study with 20,000 people and then do your analysis based on 12 different figures on your mobile phone, actually. That's one approach. Another approach is to use the full information in the study and then really look at the variation within and between clusters. And definitely a statistician is quite essential to deal with that.
Yes, I think that the comment from Alan is just another reminder that we need to stop looking at body fat as some kind of petrol tank for fuel, an inert store that does nothing. It does lots of different things, but most of the data that we have come from the obesity field. So where fat might potentially be life-saving is where we hardly have any information whatsoever. So I completely agree with that.
Just a quick comment or response about the iodine question. I'm not certain what your question was, but I think it's very important to assess urinary iodine excretion in areas where there's salt iodization programs. So if you find high levels of urinary iodine concentration, then you should review whether the iodine level in the salt should be reduced. But I'm happy to discuss this with you after the session.
Actually, sorry. A quick comment. It's actually because this is a disaster area, actually. And the iodized salt is distributed for everybody, and everybody is taking it.
Mu'tazza Shafii from National Research Center in Egypt. So my question is for Mr. Wells. You said that measuring body composition with the deuterium isotope depend on body weight, water, on the body water. So you said that this is an equation between total body water and hydration fraction. For SAM, it is always a matter of the child will have dehydration and shifting of the water from the intravascular compartment to the extravascular compartment. So how could you determine this fraction of dehydration, as it is a severe type of dehydration, and which of the groups you will put this technique to?
The answer is that we can use a combination of different techniques to try and get more information so you can assess hydration status. Some age groups are easier to work with than others because at the moment we have the PPOD, which allows you to study infants using multi-component models. And so you could combine isotopes with the PPOD and you could directly calculate hydration. And we've done that in the healthy infants, and that would be very easy to apply to the undernourished infants. Once you get past 6 months, in theory, the PPOD stops being useful. But that's actually not true for this community, because what limits the application of the PPOD is the weight of the baby. And when the manufacturers made a cut-off of 6 months, what they meant was that a typical baby who's from a well-nourished population and so on is likely to be too big at 6 months. But we've already put older infants in the PPOD in JIMA, and so we can continue to study hydration in older infants as well. When you can no longer use that approach, there are some other approaches. They become either a little more complex or a little more invasive. I don't think I'll be able to go into detail now. There's always an option if you can get the technology there. But there hasn't been, up until now, much interest in body composition. Having worked in the field for two decades, I'm always told, oh, that's really interesting. I think it's life-saving, and if that's, or potentially life-saving, I think that's what the impedance data is starting to show, that you have indications of who is at very high risk of mortality that you couldn't get from other techniques. That's interesting too, that's great, but I think it could be more important than just interesting. And I think we really need to see this technology being funded and used in these kinds of studies.
Because also you cannot treat SAM without treating the dehydration part of the problem. Then this will be misleading when you are the water composition will be misleading in this. You cannot just enroll everyone in such a technique. I think so.
No, but if you combine the techniques, you'll be able to monitor the change in hydration. So yes, we don't actually know how much of a problem it is yet, because there isn't really any data, or very, very little data on hydration in moderate malnutrition.
Yeah, now we have the second half of our session, and we have 3 presentations, all from people who have done tremendous work in the field and tried to take the best methods out there. The first presenter is Dr. Victor Ovino. Dr. Ovino is a senior lecturer and chairman at the Department of Human Nutrition and Dietetics, Technical University of Kenya. He has done a lot of work on developing and testing efficacy of nutritious foods in infants and young children. And he has a lot of experience also with application of stable isotopes for determination of not only body composition but also breast milk intake. Victor Ovino will talk about the WinFood data from Kenya and Cambodia and constraints on field procedures. Please, Victor.
Thank you, Henrik. Good afternoon, ladies and gentlemen. In the next 14 minutes, I'm going to give you a brief of what WinFood stands for, and then I'll move on to describe the methods that we used, but most importantly is to outline the cross-cutting issues around those methods in the 2 study sites, namely Kenya and Cambodia. So as a background, we know that the quality of foods, especially complementary foods, is very critical when children transition from exclusive breastfeeding to getting solid foods. We also know that in resource-poor settings, especially in Africa where I come from, these foods are typically thin gruels with very low energy density, and we also know that due to the inherent presence of anti-nutrient ligands such as phytic acid, then the nutrients that are there are really marginally bioavailable. So could we possibly utilize animal source foods, because we know that they have good quality protein, but also if you are getting animal source protein, then the iron would be more bioavailable. So really the question that we wanted to answer in WinFoods was, can indigenous animal source foods such as edible insects and small fish be incorporated into complementary foods to really address the issue of moderate acute malnutrition? So the WinFood project was funded by the Danish International Aid Agency, and the overall aim was to alleviate malnutrition by improved utilization of traditional foods that are available in various parts of the world. We had several activities, but if I merge them into 2 thematic objectives, we were to formulate nutritious foods based on fish and edible insects, and then test the palatability and acceptability. And the second thematic objective was to assess the efficacy of the developed foods on infant growth, lean mass accrual, and psychomotor development. based on a randomized controlled trial. So this study happened in 2 sites, in Kenya and Cambodia, and so far work on the development of the food and acceptability has been done and published or in various stages of publication. And if you want to know more, I just project this for your reference. So in Kenya, we developed a complementary food based on 4 food items. One was amaranth grain, the other one was edible termites, and the other one was maize, maize being the staple. And then the 4th food category was daga fish. In Cambodia, we utilized spiders and also we utilized small fish to make the product. So in Kenya, this is the kind of step we used for those, but I won't go into that. So these are the processing techniques that we used. Then we packaged the products into very beautiful plastics and, made sure that the treatment arms were identical. So then we, in Kenya, for example, screened a total of 527 mothers who had infants around 5.5 months because they were going to be getting intervention when they got to 6 months. So at the end of the day, we had some randomization into 2 food treatments, 3 food treatments, and one of them was what we called Win Food Classic. These had the small fish, the edible termites, and amaranth. Then we had what we called Win Food Light, which had no termites, no fish, but it was a blend of amaranth, maize, but then we fortified with commercial multi-micronutrient premix as used for corn soy blend plus. So then we compared with corn soy blend plus, and all foods were processed, as you saw in the flowchart, based on extrusion cooking. So these were foods that could be ready to cook for 10 minutes, and they would be very good. So we measured a lot of indicators. So we had anthropometry. We did medical examination every month. We did blood sampling for measuring lipid profile, but also essential fatty acid profile. We also did saliva sampling to measure body composition, but also we did gross motor milestones, such as standing without support, walking, and walking without support. So I go straight into the challenges we faced. So first was, how could we procure the ingredients? For example, in Kenya, termites are a seasonal, rain-fed kind of insect. They only come during long rains. So how could we sustain the supply of termites? So there are only 2 ways. You get it when it rains, or you depend on small-scale traditional practices where you actually sprinkle water on an anthill and then you beat drums in a certain rhythm so that you can induce the insects to come out. So can that be sustainable to run such a magnitude of a project? Yeah, we managed to do that, but this was a challenge. So organoleptic modifications due to the use of fish. So this was something that also manifested because mothers would come and say, I tested this, I think it has ABCD. But I'll come back to that when I talk about randomization. Yeah, but then there were also technical issues with which machine could you use? Could you actually optimize the process itself? And we found that if you added termites at more than 10% of the mix, then you could not put it through the extruder. It would block the whole system. So you would have to do with lower amounts of termite in the mix. So randomization, I'm very happy that Henrik mentioned a lot of this, so I'm just going to mention something, giving you the Kenyan context that when we do individual randomization, we are assuming these mothers live in cubicles and they don't visit each other. But actually, in the African context, these people, probably 3 women coming to the health facility, they belong to the same husband, and they'll get different food treatments, and they'll talk about it. So next time they come, they say, I think I need the packet that my neighbor is getting. So these are real things that we faced. So follow-up, high rates of dropout, vast and rough terrain, and the participants themselves, they are not stationary. Today you find them, the next day they are gone, they come after 6 months and they want to continue. Okay, so this is a mother receiving the monthly ration and we are recording the whatever. And as I've just said, they come in a row, probably their relatives, they talk among themselves. And then we have issues with standardization of measurements. So do they do it the right way, like weighing a child? I just took an example of how not to do subscapular skin fold measurement, even after a lot of energy training these people and telling them what to do. So this is a reality that you can put in a lot of effort to train people, but they cannot get it right most of the time. So then we come to deuterium oxide. Basically, for those who are not educated on this, you give a dose of 0.5 grams per kilogram body weight to a child, and then you take a pre-dose sample before you do that. Then subsequently, you take a dose at 1 hour and at 2 hours. Then you measure deuterium enrichment, and then you can be able to calculate fat-free mass and also fat mass. But we face problems in that the participants do not understand. You are telling me this is table water. Why do you measure it so well? Why don't you just give me ordinary water if you are saying this is water? So, is it easy to maintain cold chain? Because this has to be transported to Nairobi, to the lab, and it is 400 kilometers away. How do you do that in a tropical climate? The biggest issue that probably had a lot of impact on our results was spillage during dosing, because the children are agitated. So if you spill a drop of deuterium, you are sure you will not get the correct result. The other issue has to do with labeling. So you have to label this, which dose, which child, which time was it collected, and so on and so forth. Did we get it right? We tried, but these are issues that come up. The other issue is that in Kenya, for a long time, we only have one machine based at Kemri that can measure this. And it is only accessible by staff who are allowed to go there. So you may be doing a study, but you don't have control on how the samples are analyzed. So really, these are issues that are very, very real. And you can see this is an example of the dosing process. Yeah, so you put a cotton wall there, ball to draw the whatever, but you can see the mother is really not interested. This is Cambodia, and finally you collect your saliva in a tube and transport it to a lab for determination. So what about blood? So mothers are very nervous and very irritated when their children are crying. Actually, we had cases where the mother would just abandon the child there and run out of the room because the child is crying. So we have a lot of inexperience with staff, yeah, and so we feel that there need to be a lot of refresher training, yeah, to be able to really capacity build these people. What about hemolysis due to the nervousness of whoever is drawing the blood? They are not doing it the right way, so by the time you finish, almost most of your blood is hemolyzed. Yeah, lack of capacity to do analysis locally. Yeah, so we had to transport these samples to Canada for fatty acid profile analysis and to Germany for ion analysis. Is that something we want to do in future, or can we do something to make that change? So, in conclusion, I say challenges are contextual, yeah, depending on how people live and do their things. But there is a lot of misconception about interventions and procedures, especially related to blood drawing and all that. Infant morbidity and restlessness would very much affect stable isotope techniques. Inexperienced staff and lack of local sample analysis capacity would affect very much things like blood assays. So my own thinking is that going forward, we may need to think about how do we probably strengthen local capacity in terms of lab presence. Can we capacity build local staff? And also we need to sensitize the community on the meaning of the research we do, but also engage people like ethics approval committees. So lastly, I was asked to present this on behalf of the WinFood team. There are a lot of people from Cambodia, a lot of people from Kenya, and also from Denmark. So I say thank you to all of them. I say thank you to the mothers in Kenya and Cambodia, and also the entire team of the WinFood project. So this is just a sample of the authors, especially from Kenya. Thank you very much.
Thank you so much, Victor, for a very nice presentation. The next speaker is Sonja Hess. Sonja is Associate Research Nutritionist working for the Program in International and Community Nutrition, University of California, Davis. She has a master's degree in food science and engineering and a PhD in human nutrition from Switzerland. And Sonja will talk about small quantity lipid-based nutrient supplements together with malaria and diarrhea treatment, improve growth and prevent MAM in young Bukanabe children.
Thank you very much for the invitation to present my data here. Also, thanks very much to Victor. It feels like he was telling my story. I could very much understand many of his examples. I first like to declare a potential conflict of interest. This project has been funded by the Bill and Melinda Gates Foundation, and my husband has since joined the foundation as an employee. The evidence for preventive zinc supplementation given in form of syrup or tablets is quite strong in terms of preventing diarrhea and increasing growth. But when we mix zinc with food, the effect of zinc is suddenly uncertain. So the optimal dose to be added to a preventive micronutrient product, such as small quantity lipid-based nutrient supplement, is yet to be determined. So as part of the Island Zinc trial, we aimed to assess the appropriate dose of zinc in LNS by comparing biochemical and zinc-related functional responses among young children who received different zinc doses in LNS or dispersible tablets. And we compared the same outcomes with children who did or did not receive LNS and selected health services. The study was implemented in rural southwestern Burkina Faso, just north of Bobo Dioulasso. It was a community-based, partially double-blind, placebo-controlled cluster randomized trial, and we included children at the age of 9 months. We excluded children with severe anemia and referred them for treatment, and weight for lengths below 70% NCHS median. Any child with edema, chronic or congenital disease, and a potential risk of peanut allergy. The study was a cluster randomized trial, and we first identified 34 villages that were accessible during rainy season. These were then stratified into distance from Bobo Dioulasso, distance to the main road, and affiliation to health services. And then our statisticians matched those villages into 9 villages in the non-intervention cohort and 25 villages in the intervention cohort. In the non-intervention cohort, we did not intervene. We assessed children's health at 9 months and again at 18 months. And during that time, the children relied on family care and the health care. At 18 months, they then received the LNS after the study was over, for the same duration as the other children. Within the intervention trial, we randomized at the family compound because we wanted to avoid confusion and mixing of samples, mixing of food products. We had 4 groups that had different amount of zinc. Our first group here is our negative control group. The LNS had no zinc in it, and the children received a placebo tablet. And then we had 2 groups where the LNS had either 5 or 10 milligrams of zinc, and children received a placebo tablet. And then we had a positive control group where LNS had no zinc in it, but we gave zinc in the tablet format because we know from the evidence from the tablet that that has a good impact or a positive impact on diarrhea and growth. We had a retention above 80% in all children. And I'm going to present you 2 comparisons with all those outcomes. One is the comparison between the intervention and the non-intervention cohort, and one is the comparison within the 4 intervention groups. We collected hemoglobin and rapid diagnostic tests for malaria at 9 months in all children and treated all children, whether they were in the intervention or non-intervention, for malaria if they had malaria. We measured length, weight, and mid-upper arm circumference in all children at 9 and 18 months, and in the intervention cohort, we also measured it at 12 and 15 months. We assessed socioeconomic status and adherence, and I'm going to talk more about adherence later, and we assessed plasma zinc concentration in a subsample in both cohorts. In the intervention groups, we also made house visits once per week to assess morbidity, and we distributed LNS and tablets at the same time. We provided free treatment for reported diarrhea and reported fever and for any confirmed malaria. We enrolled over 3,200 children at the mean age of 9.4 months, and half of them were boys. As you can see, stunting and wasting was quite prevalent. We had 22% stunting rate and 16% wasting rate at the age of 9 months at enrollment. And hemoglobin was very low too. 91% of all children were categorized as anemic using a cutoff of 110. And RDT was positive for 61%, so meaning that children either have had malaria or currently had malaria, asymptomatic or symptomatic. For the children in the intervention group, we instructed caregivers to give the daily dose of LNS, which was 20 grams, so it was a small quantity, to divide it into 2 doses and mix it in food, one in the morning and one in the evening. We asked them also to give the tablet away from food because we wanted that the zinc in the tablet was well absorbed. We further encouraged caregivers or mothers to continue breastfeeding and to provide a large variety of local foods. And adherence, as reported, was very high. It was above 97% of caregivers said they gave LNS and tablets. But I will come back to that when I refer to our methodological challenges. This study had a very strong socioeconomic component, and we will have cost-effectiveness data, and we currently have information on willingness to pay. So Rosamond Gisou has a poster. If you are interested, please go and visit the poster and talk to Rosamond. So here are some results. We found a significant increase in all of the LNS groups, LNS health service groups, of almost a centimeter compared to the non-intervention group. But within the 4 groups, we did not find a difference in length. The same was true in weight. We found about a 300-gram increase in weight in all children. And also mid-upper arm circumference was significantly increased. But again, no differences between the 4 groups. This resulted in a reduced stunting prevalence, and I'm showing here a little different than before, that I have the 4 groups with its separate p-value, and then the IC is all 4 groups combined into intervention cohort. So there was no significant difference in the stunting rate between the 4 LNS groups, but we had a significant reduction in stunting rate from 39 to 29% at the end of the study. Similarly, the wasting rate was significantly reduced at 18 months. But here we did find a significant difference with the 10 milligrams of zinc having the highest wasting rate of 13%. So because this is a MAM conference, I of course wanted to show what prevalence of moderate to acute malnutrition we found, and we found the same difference, significant difference that we found when looking at wasting. We found that same significant difference as well in the moderate acute malnutrition children. This was marginally significant between the intervention cohort and the non-intervention cohort. Now, looking at this data, we of course were somewhat concerned that 10 milligrams of zinc could be too much, that this could be a potentially negative impact, but none of the other indicators on growth found any other differences. So weight for length and any other outcomes were not significantly different between the 4 groups. But I also wanted to look at the incidence of moderate acute malnutrition developing over the 9-month period between the 4 groups, since we don't have the middle point analysis, anthropometric measurements in the non-intervention cohort. And as you can see, there was no significant difference here when we look at the incidence of moderate acute malnutrition between the 4 groups, which makes us think that it's most likely not a negative effect of providing 10 milligrams of zinc in LNS. Hemoglobin concentration was significantly increased in children who received LNS along with malaria and diarrhea treatment and feeding practice advice compared to the non-intervention cohort. But I'd like to point out that even so, there was an increase at the end of this trial. 72% of all children were still anemic in the intervention cohort. So if we want to do something about anemia in this setting, there need to be additional interventions. To our supplies, plasma zinc concentration did not differ between any of the 5 groups. And what we really did expect was an increase in the plasma zinc concentration in the group that received zinc in form of the tablet, because in most other intervention trials, zinc given in form of tablet does in fact result in an increased plasma zinc concentration. So this made us think that maybe either adherence to the tablet or absorption from the tablet was not as good as we were hoping for. And luckily, we had put in quite a bit of effort in assessing adherence, and in retrospect, I'm glad we did, because it did help us understand what happened during the study. So we used what is most common, the case, and we asked caregivers, did you give the LNS, did you give the tablets, on a weekly basis, and recorded whether they gave 1 or 2 portions of LNS per day, or reported that they did, or whether they did not. We also collected empty and unused packages, both for the LNS as well as the tablet blisters, and calculated the disappearance rate over time. We did both of these in all children. And because we were concerned that caregivers receiving products from the project field worker might be more likely to want to please that field worker, we also had an additional team, independent from product distribution, go out and ask about adherence to the product. This was at the age of 15 months, and it was integrated in a knowledge, attitude, and practice interview that we also assessed some feeding practices and sharing of LNS and other aspects around LNS. And then in addition, we did actually a 12-hour home observation where from 6 in the morning to 6 in the evening, we were in the homes. The field workers were trained to not pay attention to LNS. Of course, that was their main reason they were there. But we didn't want to make parents aware that we didn't want anybody to change their behavior, as difficult as this is if somebody's watching you. But we did it twice, about 200 children at 11 and 16 months. And as mentioned above, we assess plasma zinc concentration to assess adherence in a more biochemical approach. So this is showing the average daily dose per child for LNS here, sort of in pink and dispersible tablets. And I'd like to point out that we had very, very high reported rates, both reported as well as disappearance rates. So the product's parents told us, yes, they gave it, and the product disappeared as well. And there was no difference whether the field worker was the one also distributing the product or whether it was an independent field worker who asked, did you give the product? In all cases, I would say almost 100% said, yes, I did give it, so above 96%. But in contrast, even so you would think that during an observation people would try to do their best, we still found a very small amount, or a surprisingly small amount of actual daily dose given. So on 59% of all days that we observed children, we observed that the product was actually given, but it wasn't always given to 100%, and if we calculated it out, how much was given over time by all over children, this resulted in 41% of the recommended dose. And the situation was even worse when it came to zinc tablets. What we also found by observing children during the whole day is that caregivers in half of the cases, so not only did they give the tablet not as often as we wish, they also gave it half of the time with food rather than away from food. So that possibly explains our lack in finding an impact on plasma zinc concentration. So the conclusion of this assessment was that we had important differences in adherence in LNS, depending on LNS and tablets, depending on the assessment used. And the 12-home observation and plasma zinc concentration suggested probably LNS and tablets were not as often consumed as caregivers reported that they actually did. So in conclusion, we found that small quantity LNS, along with selected child health services such as brief feeding advice, diarrhea and malaria treatment resulted in reduced stunting prevalence from 39 to 29%, and a reduced prevalence of wasting from 13 to 9%. It also resulted in increased linear growth, weight gain, and mid-upper arm circumference, and an increased hemoglobin concentration compared with non-intervention cohort. But the lack of impact on plasma zinc concentration suggests that there was probably an inadequate adherence to zinc tablet or inadequate absorption. So our positive control group didn't work out as well as we were hoping. And the assessment of adherence was a real challenge. And I think we should try to have some more objective tools to assess how caregivers adhere to these products. So in summary, we were unable to answer the original research question on the optimal dose of zinc because the biochemical and functional responses were not consistent. But we did find remarkable impact of small quantity LNS on selected healthcare services on growth and wasting. I'd like to thank you for your attention. Vielen Dank. And I also would like to thank all my collaborators of the IRSS in Robert Gelasso and UC Davis, and of course all the participants and parents who have really participated very nicely along with all our questions. And then, of course, many thanks to the Bill and Melinda Gates Foundation for the funding. Thank
you. We now have time for questions and answers, and Lola will take over.
Who has a question? Over there. And then over there.
My name is Mahamadou Tanimun from WFP Mali. I have two questions, one for Sonia. I would like to know the duration of the intervention given this such of change. 10 percentage points for stunting, I think we need to understand the duration of the intervention. And for Christine, also as we have used the locally basic food, which might be cheaper, it's I think important for us to know between those 4 products, which product give the best composition of after recovery. Maybe we could use only the basic food to do the intervention. It will be easy to do that. Okay, thank you.
Albert?
My name is Albert Re from Uganda. I'm concerned about the last presenter, where is stressing the use of supplemental plant nut. I have the 2 pieces here, and I've been looking at them critically. When you look at the therapeutic, rather the RUTF, the composition is giving 500 kilocalories per sachet. Likewise, even the supplemental packing is giving 500 kilocalories per sachet. The only difference between the two which I've been able to note is only the composition, where you're replacing soy milk with cow's milk. Now, taking that the two, in terms of energy, are comparable. Which guidelines are we using to give the supplemental? Because it is, to me, it is looking at the energy as the best which we are looking at. I'm also looking at this as creating a way of extra dependence on managing moderate malnutrition. Why don't we move in a way how we encourage our persons, as the resolution may be, or we could be guided through this meeting, how best we can manage acute moderate malnutrition, other than always getting on the dependency of the suppliers of these recipes, which are basically meant for therapeutic purposes. And now they are tending to confuse us, making them therapeutic, others at management level of such situations which can be handled at our community level. It's both a comment and a question to the last presenter to clarify on that.
Okay, thank you. I'll take one more question from over here.
Nelly Zabaleta from the Nutrition Research Institute in Lima. My question is for Sonia Hess. We have done 4 studies in Lima, and when we have used the DRE 5 milligram dose of zinc, we didn't have an impact on serum zinc. But when we have used 10 milligrams of zinc, we have observed an increase in serum zinc and a decrease in the deficiency of zinc. So my impression is that the DRI, that international recommendation for zinc, are for healthy children. So in our study, we didn't use it in MAM children, where, however, I think that in this context, that for developing countries and also for MAM, probably the recommendation of micronutrients like zinc should be reviewed. So maybe this is also applied to other micronutrients.
Can I ask Sonia, then Christine, to address those questions?
First, my apologies for not telling you how long the intervention was. It was 9 months. Of course, I was meaning to tell you that. Thanks for pointing that out. And your question, so there is actually activities going on to review the physiological requirement, as well as the upper level, the UL for zinc, because the UL is considered too low as well, and so we should hear hopefully soon of more harmonized, also across more different countries and agencies, what the dietary requirements are.
Okay, to respond to the 2 questions. So the first question from our colleague at WFP Mali, it's nice to see you. So the question was about which of the 4 supplements are best. As I mentioned, they all provided the same amount of calories. There were some differences in the macronutrient composition. I didn't show the differences in the micronutrient composition. There are differences, and it depends what micronutrient we're interested in looking at. So I think it's a little hard to answer that question in terms of which product was associated with the greatest gains in this subgroup, and also in the overall trial we saw the greatest benefit was with the supplementary Plumpy group. However, we did see improvements in the other groups as well. Cost effectiveness analysis will be is underway to help answer the question, to better kind of look at the overall picture. So hopefully that will be helpful. And the question about RUTF versus RUSF, or supplementary Plumpy versus Plumpy Nut. So supplementary Plumpy is intended to act as a supplement to the usual home diet, whereas RUTF is meant to be the sole source of food for children with severe acute malnutrition. I believe that the micronutrient composition is different for RUSF versus RUTF, because the amount that they're consuming is different. So in our study, children were, it was recommended to provide 1 sachet per day, whereas a child who would be consuming RUTF would be likely consuming multiple sachets, but it would depend based on, their weight and their age and their height. So there are differences there. The main difference is supplementary Plumpy is meant to supplement the home diet, and this was conducted, the study population was a food insecure population, and really that was the purpose of the trial. We were not advocating that supplementary Plumpy was best, but it was a trial to evaluate the effectiveness of 4 different interventions, of which supplementary Plumpy was one, but we also looked at 3 other different interventions.
Any more questions? 2 from here and 2 from there.
Yes, hello, Professor Fries. I asked you before lunch about endogenous foods for these sorts of interventions, and you said that there would perhaps be further discussions after lunch. But the endogenous foods we've had described today are all processed foods. What I was much more interested in was actually home-cooked foods. And I wondered if you had any thoughts on whether any work is going on in this line or not. Because even if a processed food is produced in country, the problem with countries like Bangladesh is the huge commercial avenues that these things open up. For example, the pharmaceutical industry, I don't know if you know in Bangladesh, in the UK you probably get 5 types of amoxicillin produced by 5 different companies. Not even that perhaps, but in Bangladesh you have 30 companies producing amoxicillin. So when you put a commercial product on the market, such as Plumpy Nut or subsequent other products, this will open up. It will explode in terms of the companies who are going to come into the market with these products, and they will not come with randomized control trials, and they will say that your child is thin, your child is malnourished, this is what you need. And this we've seen with the pharmaceutical industry in our country, and we have seen it with the infant formula industry in our country, and we are likely to see this with the products that have been proposed at this meeting so far. So I would be much more in favor to save our people from such commercial exploitation in home-cooked foods. So I think I urgently call for trials with home-cooked foods so that such commercial exploitation does not take place. Thank you.
Hi, Charlotte Wright from Glasgow University. My comment was that the size of the supplement, like 500 calories would be about a third or up to half a child's usual intake. If it entirely added to their diet, it might increase it by 50%. But in practice, it's going to displace a lot of family foods. And my question is, you talk about assessing effectiveness, but you didn't have a control group, so you don't actually know whether any of these things are effective in the long run. You just know how they compare to each other. And my question would be, what happens when you stop? And where are the children's feeding skills and taste for family foods left when you stop?
My question is about the cost of delivery mechanisms of most of these supplementary programs that we have. Often you'll find that in a research setting, this is done, it's effective, and I think we know that most of them are effective. And in some countries, it would be a donor that's funding, but when they leave, the delivery mechanisms cost much more than the product itself. And the monitoring and the systems that you must put in place, whereas if you had focused on the basics, it would cost much less. Has anybody done costs of these interventions if they are scaled up at a country level?
Just capture that last bit. Has anybody done costing of these interventions when?
The delivery of the interventions often costs more than the actual product itself. And more often when they are introduced to a country, you are often told about the cost of the product. But the systems that you must put in place for making sure that it's delivered effectively, monitored and whatever, we often don't know how much that costs. And when you start implementing it, you then realize that this thing actually costs much more than what it's supposed to be. So has anybody done any costing of those if you have to scale up?
I might put that question out to Anne, Dominique, or others from ACF if they're in the room. Can you just take that last question?
Yeah, just quickly, sorry, I've forgotten your name, but on the LNS, you did say that there are situations where mothers were giving the LNS together with food or something like that. Yeah, but given what LNS is, it's for a mother it will be a common sense that you kind of give it with food because they will always consider it as if it's like, butter, bread. So is it really like a requirement that it must be given on its own, or shouldn't it be given with food? Is my question. And then the second question I have is on the amount of the supplementary plumpy, the kilocalories, the 500. I know that in a number of emergency contexts we have always recommended 500 to up to 1,000, sometimes 1,200 because of the sharing and all that. But is this 500 really completely consumed in this study? Are there issues around, sharing or that amount not being taken fully? And if so, then what's the, what does that mean? Thank you.
Okay, can we start with Hans to address that question around Dr. Tlukta's question about products?
Thank you very much. And sorry I misunderstood it in the first round. To be frank, I'm not aware of any such studies, and I guess it will probably not be home-cooked foods that will be assessed in big trials because of the cost and the difficulty of applying the findings from such a study. Maybe my colleague Victor Vino can elaborate a little bit more on it later on, but we thought at least that locally produced foods, even if it had to involve some industrial processing, was a much better option than, for example, in Cambodia, where people, if they are in need as part of food programs, are receiving corn-soy blends, which are not highly appreciated, and has to be taken the whole way around the globe in order to come to Cambodia, when people really wanted something that was rice-based and contained some of the local foods. So even if it becomes more expensive, it may leave some benefits for local people to find, harvest the ingredients and process the foods. And still something that can be scaled up at least to some extent. So that's where I think that a trial can be justified. Getting good evidence for all the different home-cooked foods may be more difficult.
Yeah, so just to add, probably I want us to look at the household It is not not just the child that we are targeting with the intervention, but it is the other people who must survive. They must eat, they must get soap. So there has to be someone to really look for that ability for the household to survive. And in most cases, it is the mother. And increasingly, even where we come from, mothers are no longer at home. So while I agree with you that we need to promote more home foods and the traditional ways that they've been processed before, I would look at it in a way that how can I take care of the mother who has to look for survival means for the family? Otherwise, we go into food insecurity for the rest of the household. So I would look at it in terms of what is the opportunity cost if probably we took these foods learned from the traditional processing methodologies like fermentation and we did it at small-scale industrial setting so that we take care of hygiene and we take care of, palatability. Probably that, to me, is a good way to go. And I just wanted to also comment on the issue of cost effectiveness. I know not of any study that has done any scale-up after the trial, but at least I know of studies like one I was involved in Zambia with Valid Nutrition, where we actually did cost-effective analysis of RUTF nested in MAM program. And actually they are cost-effective, so the only thing is that there are never resources to really follow up interventions. So probably what we should be asking, can we be integrating into the budget as we plan studies, can we come back and do cost-effectiveness analysis and also do some small-scale scale-up so that we see how it works? Probably that, to me, is the way to go. Thank you.
Sonia, then Christine.
Yes. About the cost of delivering and cost of production, our project has a very strong socioeconomic and economic health component. So there will be cost effectiveness calculated, as well as there's a lot of calculations being done on the production cost, transportation cost, and distribution costs. That's forthcoming. I've seen internal presentations on it. It's very interesting data and very important data, so I very much agree with you. I would like to mention and repeat again that we do also consider a willingness to pay as through social marketing. We're not, at this point we are testing what potential the product has, but also what demand there is from the families. And Rosemont Gisu, who has a poster 112, she has much experience in how the community is interested in the product as well as potential purchasing it. And there are trials going on with local boutiques at the moment where they're selling it through social marketing and see how people just buy it or not. The other question about the LNS mixed with food, I'd like to clarify that we had two products. One product was LNS in our study. One product was LNS, and we actually did advise to mix it with food. But we also learned that all mothers around the world like convenience, and so very often they mixed it with food. But very often they also gave it as a sort of snack to the child just to eat like that. But that's what happens in the real world. And the tablet was asked to be given away from food just to avoid that phytase would interact with zinc.
Okay, to respond to the question about, or the comment that was made, well, all four groups received the 500 calories per day. That's true. We didn't have a control group that received no food. There were a couple of reasons for that in the study design. One is Mali has a national policy for the treatment of moderate acute malnutrition that provides food. And that's in their national policy, so we didn't feel we could stray from that. In this particular study area as well, the community health centers were used to receiving food and providing food for children with moderate acute malnutrition. So sort of from an ethical perspective, it wasn't possible, also given the context of food insecurity. But I think it is an interesting question. I think it would also be interesting to look at sort of to do a dose response trial to look at different amounts of supplements to identify is 500 calories appropriate, is 200 calories more appropriate or more effective, or is more needed? So I think that's another question that could be explored. There was another comment or question about the 500 calories per day, and do we know how much was consumed versus how much was shared amongst other members of the household? We asked mothers or caregivers to return to the regular clinic visits with the packages, which isn't necessarily an ideal measure of compliance, as Sonia discussed. I don't have those data at my fingertips right now, but we did measure that. Unfortunately, we were hoping to be able to do home observations where we would actually watch how the different supplements were prepared and provided to the child in the home, and it logistically wasn't possible. I think that would provide kind of more insight into what was going on in the household.
Okay, thank you. I'm not going to take any more questions. I'm so sorry. Over to Hans to wrap up.
Henrik. Don't mind. Thanks a lot. First, I would like to say thanks to the speakers and to the rapporteurs, but also to the audience for all the questions and the attention and the good discussion. I think that during the whole conference, we've heard a lot about the lessons that can be learned from the field and from operational research. And in this session, we have tried to focus more on technical methodological issues, both from a theoretical but also from a practical point of view, and those issues that are important to get really to enable us to assess the effect of nutritional interventions. And I really hope that and believe that this exchange of information between people working in the field and researchers can be very fruitful. For example, if the input to researchers might increase the relevance of their research and let them think about the need to incorporate process evaluation, as it was mentioned, but also the other way around, that maybe program people will try to take up some better methods, or even if program people and researchers could see an opportunity to link up and to carry out research and operations together. I think that would be very nice. So I'll end by saying thanks to the agency for inviting us and having this session. Thank you.
Thank you, Henrik, very much.